So, have you ever stopped to wonder how some of these massive tech companies can update their apps not just every day, but sometimes what feels like every hour? I mean, how is that even possible? Okay, let's get into it.
All right, welcome. In this explainer, we're going to pull back the curtain on the magic behind all that high-speed software delivery. We're going to demystify the DevOps toolchain and really give you a solid mental model of how all these different pieces actually fit together.
And the scale we're talking about here is just staggering. Atlassian points out that while a typical project might see maybe 20 changes a day, some of the really big ones are deploying over 100 code changes into production every single day.
So, how in the world do they manage that kind of velocity without everything just breaking? Well, the secret isn't some single magic tool. It's actually a whole collection of them, all working together in this seamless automated flow. And that is what we call the DevOps toolchain.
And here's the more, official definition from Atlassian. The really key word here is integrated. This isn't just about one phase like coding or another phase like testing. A real toolchain covers the entire lifecycle of a product, from the very first idea all the way to monitoring the app running in the hands of real users.
So let's start with the absolute heart of the operation. If the whole toolchain is a car, then what we're about to talk about, well, that's the engine. We're talking about the automation pipeline.
At its very core, DevOps is all about creating this automated process that can take a developer's code and get it out to the world safely and, more importantly, quickly. This process is called a CI/CD pipeline. It stands for continuous integration and continuous delivery, and a tool like Jenkins is often the master conductor here, the one kicking off the whole automated sequence.
Okay, so let's just walk through the basic flow, step by step. It all kicks off when an engineer commits their new code. Right away, a CI server like Jenkins grabs it, builds the application, and runs a whole bunch of tests. If everything passes, the code gets neatly packaged into this standard portable unit called a Docker container. You can think of it like a self-contained box with the app and everything it needs to run inside. And finally, that container gets deployed to a cloud environment, like AWS. And the best part? All of this happens automatically.
Okay, so that pipeline is great for one application. But what happens when you have hundreds of applications and each one is built from dozens of smaller independent parts we call microservices? All of a sudden, you're not running one container, you're running thousands of them. You've solved one problem for sure, but you've just created this brand new massive management headache.
Yeah, this creates a whole new set of problems at scale. For example, when a container just fails, how do you restart it? Well, that's where a container orchestrator like Kubernetes comes in with its auto-healing. How do all these thousands of containers talk to each other across different servers? Kubernetes simplifies the networking. What about a sudden spike in traffic? Kubernetes makes scaling up your application incredibly easy. So the key takeaway is that Kubernetes automates the operation of all these containers when you're dealing with massive scale.
Okay, great. So Kubernetes is wrangling our thousands of containers for us, all automatically. But with so much happening all at once, you can't possibly sit there and read the logs for every single one. So how do you even know when something breaks?
The short answer is you don't. Not manually anyway. You need automatic monitoring. You need tools that are constantly watching the health of your entire system. A really popular choice for this is Prometheus. It collects data from literally everything. Your apps, your servers, Kubernetes itself, and if something looks off, like a server is getting overloaded, it automatically sends an alert so an engineer can jump in and investigate.
So we've automated the application pipeline, and we've automated the operation of our containers. What's left? Well, what about the servers, the databases, the firewalls? The entire kingdom that all of this stuff runs on top of.
Just imagine the worst case scenario, a major misconfiguration or even worse, a security breach, and it takes your entire system down. It's just gone. Rebuilding thousands of servers, networks, and all their configurations by hand would be an absolute nightmare. We're talking weeks, maybe even months of work.
And this is where a practice called infrastructure as code comes in, and this quote from the tech world with Nana Channel just sums it up perfectly. You use a tool like Terraform to write code that's basically a blueprint for your entire infrastructure. If anything ever happens, you don't rebuild it by hand. Nope. You just run the script again and it automatically recreates everything from scratch exactly the way it was before. It's amazing.
And for managing the software on those servers, things like installing security patches or upgrading a program across thousands of machines, we use what are called configuration management tools. Ansible is a really popular one.
You write a script once, tell it which servers to target, and boom, it automatically pushes those changes out to all of them.
So far, we've been focusing on these big, automated systems that run in the background. But what about the foundational tools? The stuff that engineers are actually using with their hands every single day to build all this automation in the first place.
These are the fundamentals, the absolute bedrock. You've got Git, which is where you store and collaborate on all the code we've talked about, the application code, the pipeline code, even the infrastructure code. Then there's the Linux command line. That's the environment where most of these tools live and breathe. And finally, you have a good code editor, something like VS Code, which is the workbench where engineers write it all.
Okay, we've covered a lot of different tools, but how does a company actually decide which ones to use? Well, there's no single right answer. It really comes down to a choice between two main philosophies for how you build your toolchain.
So fundamentally, there are two paths a team can take. On one side, you have the all-in-one toolchain that you get from a single company. This is awesome for beginners because it's super fast to get started, but the downside is it can be a jack of all trades, master of none. On the other side, you've got a customizable toolchain where you mix and match the best tools for each specific job. This is great because teams can use tools they already know and love, but, and this is a big but, you have to make sure they're all tightly integrated, otherwise you'll just end up with chaos.
So when you really get down to it, a DevOps toolchain is way more than just a list of software. It's the engine that powers modern development, for sure, but it's also a deep reflection of a team's culture and their strategy. It's all about picking the right tools that work together to break down walls and help everyone move faster. So the real question you have to ask is, what's the right philosophy for you?